And welcome to the Daily Space Weather. Smasho here, coming at you from the Smash News Network, least busted name in news. We've got a pretty quiet eastern limb of the closest star and a pretty loud western limb. Likelihood of major flares by tomorrow at this time will have dropped a bit. We'll tell you all about it. First, let's take a closer look at the eastern portion of the closest star here, and huge filaments in the southern hemisphere are definitely one feature to talk about. So there are significant filaments there, and we've been naming them after living people, so make sure you hit us up on Twitter if you want to name filaments. The western limb, a lot less quiet. So the likelihood of an X flare or multiple X flares even coming from that area will continue for the next about 24 hours. After that, the likelihood of that will drop precipitously. So the possibility of huge coronal mass ejections and large solar flares remains throughout the day today. You could see massive radio blackouts over the U.S. There is the southwestern portion. And let's take a brief look at sunspots. So we did have some modest growth up here. In fact, this might even be a new group. I think that'll get named a new group actually before it sets. So there's some activity. Here is some more growth right here. So a little bit of growth in the northern hemisphere. The southern hemisphere down to 0 sunspots here, south of the solar equator. Colorized magnetograms next. These areas down here are plages. We don't see any new sunspot groups up here yet, but we do see some activity likely to rise here in a couple of days. So let's take a brief look at volcanoes. There's some imagery of Krakatoa, which has produced some short but intense lava fountaining. Suwanosei-jima is producing a 5,000-foot ash plume. Krakatoa! Those lava fountaining episodes are called paroxysms. And no indication on the flight level there. Don't fly your hang glider over Krakatoa. Mount Yasur exploding. That's on Vanuatu. The public was reminded not to enter the area within 600 meters around the cone. And please do not pole vault the caldera. Popocatépetl exploding, flight level 210. Nevado del Ruiz exploding, flight level 220. It's a 22,000-foot ash plume over Colombia. Some seismic activity there as well. Don't fly your John Denver-style ultralight aircraft over Nevado del Ruiz. Sangay in Ecuador exploding, flight level 190. It's a 19,000-foot ash plume, 15,000-foot ash plume over Revenador in that same country. A third volcano also erupting there. Cotopaxi exploding, flight level 200. It's a 20,000-foot ash plume. And Sabancaya also exploding, flight level 240 over Peru. It's a 24,000-foot ash plume. And let's take a look at seismicity. The last 90 days are looking like this. And no major quakes have occurred over the past 24 hours. I stand corrected. One occurred while we were doing the live stream. So we'll get to that at the end of this report. Up until just 5 minutes ago, the largest quake of the past 24 hours was a 5.9 at Greece. That came in at 12:37 Universal Time yesterday. And let's report on all of the 5+ magnitude quakes. So Kermadec Islands region had a 5.0, which now looks like a foreshock. There were a few China quakes in China quake, the quakes that are made in China, okay? If those would have been U.S. quakes, they would have been at least a magnitude 9. They would have been the most amazing, spectacular, and stupendously superb earthquake that you ever saw, okay? There was also a 5.5. Also another 5.0 at the Kermadec Islands region. And some additional aftershocks there at China. Again, remember, folks, any earthquake can be a foreshock. A prime example of this is this most recent quake here, which we'll get to. First, there was an interesting one here at Porto Novo, Cabo Verde, off the coast of Africa there, a 5.3. And then a 5.7 at Indonesia, only occurring 7 minutes later on the opposite side of the Pacific Ocean. Some small quakes around California, and there we go. There's the largest quake of the past 24, a 6.0 at New Zealand. Let's take a brief look at the location of that one. Was it in the ocean? Indeed it was. In the Kermadec Trench region there, north-northeast of New Zealand. That 6.0 came in at 10:45 Universal Time this morning, which brings us back to space. So we pride ourselves on producing the most detailed imagery you'll find anywhere of the closest star. So here is some, and thanks for leaving a comment, Tinman1057. So here is just ionized helium by itself. A classic view there, 304 angstroms from SDO. Let's spice things up a little bit by adding another wavelength here. So here is 211 angstroms added to that. That's ionized iron. It shows the extended corona, and it's great at showing coronal holes and some filamentary activity, like prominences especially. And let's change it up again. Get rid of the 211 angstroms and add 193 angstroms. This is actually what we started out with. This is probably the best series of wavelengths to show solar filaments. And, well, a special type of filaments known as solar prominences. So, solar prominences are simply when a filament is hanging off of the limb. And as you can see, we've got a huge one up here, and it's getting less likely to be sent toward Earth. If we do see a major flare, it's now much more likely to be headed off sort of in the opposite direction, well off to the northwest. But the possibility still lies there for Earth-directed coronal mass ejections, as there are a lot of filaments in the earthly portion of the solar disk. Last but not least, we've removed 304 angstroms here and added 171 to 193. This shows the extended and lower corona, so lots of definition there for the solar atmosphere. And continuing on, the 10.7 centimeter radial flux now has dropped down to 172 solar flux units. So if you're wondering what a solar flux unit is, it's 10,000 joules of radial flux density. There's the 1 year graph to put it in context. The black line is the 10.7 centimeter radial flux, which made it all the way up to 234 solar flux units at the rather recent height of solar activity so far in solar cycle 25. And keep in mind, we are a couple of years from solar maximum, so expect to see lots more activity in the coming months and years on the channel. Next, looking at the Space Weather Enthusiast dashboard, and no geomagnetic unrest or geomagnetic storm conditions are forecasted by NOAA here. We are seeing some indications of a fairly weak coronal hole high-speed stream showing up. We'll get to it here in a moment. First, let's take a look at the earthly geospace. KP index right now at 3 for the past about 6 hours. KP3 is the planetary K index. And here are the last 4 hours of Earth's magnetic moment from space. This imagery depicts magnetohydrodynamic pressure as modeled by the Space Weather Modeling Framework. Earth's magnetic moment from space to about 12 Earth diameters. And here's Earth's magnetic moment from the ground. This depicts magnetic flux density, or nanotesla geospace. Delta P is a reference to changes in Earth's B field. The B field being the field that goes through the magnet. This magnet being Earth. And wait till the bonus features segment. Some interesting stuff going on in Earth's magnetic fields indeed. So looking at the real-time solar wind here, we did see an increase, at least when we switched from the ACE to the Discover, which is the green to blue line transition down here at the bottom. But current conditions are looking like a little bit of an uptick there in the solar wind density. Current conditions are about 11 protons per cubic centimeter for the solar wind density, solar wind speed 480 kilometers per second. We are expecting a dip in the density and an increase in the solar wind speed here. We're seeing a very late arrival of a coronal hole high-speed stream. Maybe it missed entirely. But the GOES magnetometers here are giving us some indication that there is something arriving here, because we're seeing quite irregular patterns there. A huge divergence happened around midnight local time for the GOES 18. As you can see, this blue line dipping while the red line rises. The N's and M's are noon and midnight local time for the GOES 16 and GOES 18 satellites. Next, we'll look at more magnetic data. But first, let's talk about supporting the channel. If you want to support the channel, one of the ways you can do it is by picking up some merch. So some of the merch may be controversial. Some of it's just for the lulz. And we put out merch because reasons. So there's all kinds of reasons to put out merch, whether it's to start a conversation, to make somebody mad, or to commemorate the pathetic response to certain types of microscopic agents. So get yourself a souvenir. This is a re-release. Today's featured product is Smash Our Price, My First Pandemic. It's one of our first releases, and we re-released it because of the lulz. Because reasons. So get yourself a souvenir, and congratulations on surviving a global scamdemic so far. A global pandemic. Congratulations on surviving one so far. I'm sure various bureaucrats really helped with the likelihood that you and your loved ones have survived. So don't forget to thank your friends and foes about all the great work they've done masking the planet. They're doing a fine job out there. A fine job. You can also support the channel by becoming a patron. So we are still on Patreon, although we did replace Patreon with our own subscription services site. If you find it more convenient to support the channel this way, support the channel via Patreon. Increase the likelihood that these videos will continue to exist and remain publicly visible. The official subscription services site of the Smash News Network, least busted name of news, and thanks for leaving a comment, Sir Giddy615, is SmashOnMash.com/Smash Team. We launched it back in October of 2021. The best value is the gold annual paid-up subscription, because we will send you complimentary merch. It's almost like getting 4 months of a gold subscription at no cost. So thanks to all of our Smash Team members at the gold and silver levels especially. There's also a bronze membership level. We do send out email alerts about various things like natural disasters. And when we put up our major video releases, since we don't trust certain organizations to notify our viewers, make sure you click posts to see the latest posts, and make sure you log in to see the posts that you're authorized to see at your Smash Team level membership. Silver level's only $2.99 a month. Thanks again to the Smash Team. There's also a bronze level, which costs you just nothing. And email alerts go out to all levels. Next, looking at the heliospheric current sheet and the polarity of the plasma. So Earth has now snapped into a South Pole current sheet. No surprises there. It's pretty consistent, although we do see some activity here. So here's an indication that we may see some sunspots about to show up in the southern hemisphere, as we see some North Pole current sheets snapping through there. So that's a great way to forecast, by the way, the top view ecliptic plane field plot. If you know how to read the data, it is quite definitive. And we hope our regular viewers are used to looking at this, as we've been showing it for a few years now, as we push the 6-year mark on producing the most detailed space weather videos in the world. Next, our line of sight field plot. Here's the sun's B field depicted in blue. North solar field in green, south solar field in red, and let's move to coronal holes, as we've got some South Pole oriented ones rotating in here and becoming a little more well defined through the bumpy corona. There is our line of sight coronal hole plot, and let's take a look at it from the perspective of SDO. So here we've got another trans-equatorial coronal hole system rotating in. So here's a great example of North Pole-oriented coronal hole, South Pole-oriented coronal hole. That's 211 angstroms from SDO, and that is the last 24 hours. Most of our custom HelioViewer movies are 24 hours. Next, we'll move to sunspots. And again, we have seen some sunspot growth here. Just no major changes. We may have one more named sunspot group today, so we may see a little increase in the sunspot number. I believe this group in here, there's a group right there, I think that may get a name here. It is associated with another sunspot, but I think it is its own new group. So anyway, likelihood of major solar flares here still remains very, very high, at least for the next 12 hours. I'll say the next 18 hours. So after about 18 hours, the likelihood of major flares will drop, as most of the suspended plasma by those massive sunspots setting in the western hemisphere will be out of sight. So here is 304 angstroms plus SDO continuum. We'll also zoom in. And Sir Giddy615 says, sure would like to see you have an interview/debate with Eric Briggs. Is that angry catfish Briggs? Because he talks a lot of nonsense about space weather. So, I mean, I'm basically open to go on to any channel, especially if it has like 1,000 times more subscribers than we do, like his silly channel does. So, I mean, drop him a line. If he invites me, I'll go. I'll debate whoever. I don't need to do any research either. Anyway, here is the SDO continuum by itself. Again, I think we're going to have another new sunspot group. I think this is going to be a new group. And we do have some growth in some spots as well. But for the most part here, solar activity kind of dropping over the past 24 hours. And we'll see a big dip in the sunspot number with the setting of this massive sunspot down here. That could be the largest single umbra we saw throughout the entire solar cycle. So next we'll get to energetic particles here. After that plays through, no spikes in the GOES proton flux, so no relativistic particles showing up. Relativistic particles can arrive as early as 20 minutes after a major solar flare. At the moment, nothing doing. So we have had 3 M-class flares in the past 24 hours. And, well, in the past, I'll say in the past the past 2 days, we've had 3 M-class flares. And let's take a look at some composite imagery here. Here's 131 plus 94 angstroms. And the flaring did indeed come from those setting regions on the western limb, so let's zoom in on that. That, my friends, is some fine, fine imagery. And thank goodness for the SDO. I think it remains my favorite telescope, although the James Webb definitely has potential. And, well, I've been a fan of the Hubble since the day it was launched. Anyway, let's take a moment to look at a star chart. So this is the skyandtelescope.org star chart. I'm going to press now to advance this to where we are at the moment. And if you look up high in the sky, you may see Spica near the peak of the ecliptic plane there, which is this bluish line here. Spica, part of the constellation Virgo. And if you want to read about that, there's a great Wikipedia article about it. It's an interesting binary system, a rotating ellipsoidal variable system, where the periodicity there of the stars orbiting each other is only 4 days. And it's not an eclipsing binary, it's a different type where the light is reflecting off of the other stars and they're not very reflective and so on. But anyway, if you want to read about Spica, it's an important star in the realm of astronomy, as it's been used to calculate things like distances to other stars. And let's do a solar system forecast. So here's where items in the solar system are located now. Let's move this ahead 1 week. That's where things will be on a 2/2/2023. We're only 6 days from February, folks. How time flies when you are overworked and underpaid. Next, Looking at yesterday's coronagraph imagery to see a lot of missing frames there, only 28 frames. And we'll show some frames from today also. There's additional 16 frames. You may be wondering if there's an Earth-directed coronal mass ejection, and we're going to cover it by looking at Stereo A's coronagraph to give us a little bit of additional perspective. We'll also look at the coronagraph from Soho Lasco C3 at Lagrange 1. So we pause this here at 12:09 and 12:06. So for you new viewers out there, Earth would be off in this direction from Stereo A. And the reason that we paused it right there is because, indeed, there could be a tiny earthly component there. So you see a little bit of diffuse material kind of right here on that line. Now, when we look at it from the perspective of the Soho Lasco C3, we don't see much of a halo there, if anything, but there could be a small earthly component there, a very diffuse bit of material. If that is going to arrive at Earth, you can expect to see it early in the day on the 29th. So maybe late in the day on the 28th, but early in the day on the 29th is the best guess. Let's bring these back. Keep in mind they are different periods of time there. Please note the time and date stamps at the bottom, and we'll show you some 24-hour videos here after these play through. So let us know in the comments if you think that is an earthly directed component there. If it is, it will be very minor. It's not going to be highly detectable. It may show a minor signal there. We might see a little bit of a CME impact, and it probably won't cause very much effect on Earth at all because, well, Earth's magnetic field, it's not going away. In fact, it might be returning to normal, so the polar excursion may be ending, and we see lots of evidence of that. So things are getting less and less scary in space. And by the way, if stars are made of condensed matter as opposed to gaseous plasmas, guess what? They're more stable than mostly everybody believes as well. So there's the past 24 hours with our coronagraphs and SDO 304 angstroms. Here's a zoom out. And we'll zoom out even farther. And I'll note at this point in time that we've never seen the birth of a star, the death of a star, or much any of the evolution, really. That's sort of widely believed to be a thing. So this is all theoretical stuff, and a lot of the thinking as to how stars born, die, and evolve is some 1850s thinking. So anyway, this brings us to filaments, because we've got major filaments, and we've been naming them on Twitter. So here are filaments. So we've got this one here. This one's already named. That's the James Comer filament, named by our viewer Julie. He's some kind of Kentuckian politician or something. And I think we should probably name these two filaments. So this one down here in the south, and this one in the southeast. I think those are good candidates to get named. This one here might already be named. I can't remember. It's a little bit too much. So let's take the last image here from Udaipur, India's ground-based solar observatory, say copy, and then drop by Twitter. So make sure you follow us over on Twitter. You'll see information that is only available there as we say name that filament. What in the hell? There we go. So again, this filament here, this one over here, and don't name this one. It's already the James Comer. And to name a filament, you got to name it after a living person, and you have to tweet. So you have to either comment on our tweet, we'll retweet that for you or whatever, or you could tag us in a tweet of your own and we'll retweet that. So thanks to our Twitter followers. Thanks for tolerating the pathetic, putrid, disgusting, and ridiculous censorship that continues on the platform that a lot of hack frauds who have no idea what they're talking about on the internet think Elon has fixed, which he hasn't done at all. The deboosting features remain in place. And let's take a look at the last 24 hours from SDO 171 angstroms, the house favorite wavelength. And man, that is some good imagery. Thank goodness for the SDO. The Solar Dynamics Observatory does not often disappoint. We'll also show the last couple of hours here from GOES 16 SUVi with its awesome wide field of view. It's great at showing solar prominences and CMEs as they happen. It's why we stream it regularly on the Twitch channel. If you haven't checked it out, it's twitch.tv/smashamash. Links in the description to that. We'll be streaming it all day today, so if you want to see what's going on from the GOES 16 SUVi, feel free to view it on the Twitch channel. So again, likelihood of major solar flares still remaining here for another about 18 hours, I'll say. And don't be surprised to see coronal mass ejections, even earthly directed ones, as coronal mass ejections do not require sunspots or solar flares. We covered many, many coronal mass ejections at solar minimum on 0 sunspot days. Continuing on to our bonus features segment. We're looking at satellite charging hazards. We have some surface charging here over the Eastern Pacific and some more minor surface charging hazards over the Eastern Caribbean, Central America, Mexico, and the Central Pacific. Those are caused by low-energy electrons building up on the surfaces of satellites. Next, the GOES electron flux over the past 3 days. We do see it dipping down here. So this is an indication. This is something that we typically see with coronal hole high-speed streams as well. So don't be surprised to see the solar wind density drop and the solar wind speed come up. That coronal hole high-speed stream seems to be a little bit late for the party, but we'll admit it anyway. So here we're seeing higher than expected levels of electron flux. Looks like NOAA must have agreed with our forecast for a coronal hole high-speed stream, but it hasn't shown up in earnest. That is the relativistic electron forecast model by NOAA. NOAA expecting a big increase in the electron flux. I'm expecting a continued decrease in the electron flux. There's the one-year chart to put that in context. And we're just in an operating range here. Pretty unremarkable levels of greater than 2 mega electron volt electron fluence. Now that electron flux is measured at the F layer of the ionosphere, which is located at 300 kilometers of altitude. So let's take a look at that vibrational frequency, since it gives us such awesome insight into the oddities going on in Earth's magnetic field. So this is a prime example here of how the magnetic excursion may be ending, because you would expect the weak points in Earth's magnetic field to be around the equator, which means if the South Atlantic anomaly has moved from the South Atlantic to the South American continent to the South Pacific, and now is moving back toward the equator, which is what we see happening in this imagery, if that just stops at the equator, that looks like the end of the polar excursion. Now, I do hear people talking about how the Earth's magnetic fields are moving back toward the geographic poles again. And the most likely situation in a magnetic excursion, by the way, folks, is for it to end with more stable fields. The likelihood of it to lead to a magnetic pole reversal is incredibly low, statistically speaking, in comparison to its likelihood of snapping back to geographic polar normality. Anyway, let's bring up the latest image here and show the anomalygram, since the South Atlantic anomaly has moved into the South Pacific and is now, well, farther north. So it was right about here where my pointer is. And now it's up here closer to the equator. So it is moving to the north. And yeah, that's an indication that the polar excursion is ending, folks. So I don't know how many careers on YouTube that's going to end, but I don't really care, because we prefer to just cite facts and let the chips fall where they may. So there's your anomalygram. That's anomaly in megahertz from a 30-day median. South Atlantic anomaly once again on the move here. Where it will end is likely at the equator, which is where it belongs. That's what a spherical magnet does. Anyway, there's the wait a minute. There's the latest image, 11:30 Universal Time ionogram, and there's the anomalygram. We'll also show the total electron content forecast. That is the free electrons between your GPS satellite and your handset. Free electrons can cause massive signal refraction, and your GPS could be off by thousands of miles as a result. You might go on a bike ride with an average speed of 10,000 miles per hour as a result of GPS errors. And we are still seeing continued anomalies here. So huge anomalies in terms of these low electron content bands Also, these low electron content regions over the Caribbean and over southern South America. And also huge GPS errors all around the world. So some extremely chaotic stuff going on here with the total electron content forecast. Expect GPS errors. We'll let this play through one more time. Those red areas are very likely to see massive GPS errors, so perhaps turn on your Wi-Fi location accuracy if you're navigating. If there are Wi-Fi hotspots, that will help to calculate your position. And we'll close out our space weather portion of the video with the latest intensitygram and latest SDO magnetogram. So the first thing you're probably wondering is if these are sunspots, and the answer is no. Now there is another active region rising up here also, right up here. Are they sunspots? The answer is no. So anyway, here's the rock back. We'll see a huge dip in the sunspot number today. Also, the radio flux will be dropping over the next day or so. In all likelihood, keep in mind the environment can suddenly change out there. So don't be surprised to see some breaking news coming through from the Smash News Network, least busted name in news. And now we'll transition to our meteorology segment, and we'll start out by looking at the UV index. I just want to show you a little bit about how the UV index works and why you see these variations. So it might look like something to be very frightened of. Oh my God, there's a spiral-shaped thing happening here in the UV index and a spiral-shaped thing happening here. It must be radiation from space, folks. Oh my God. And it is radiation from space. But if you look at the total cloud water, it's because those are low-pressure zones. So you can see the clockwise rotation of those regions right there. It's because it's cloudy, which drops the UV index. Yeah, clouds. Clouds produce shade under them, which makes less UV at the surface. So there's nothing paranormal, mystical, or frightening about it, although somebody on YouTube can probably find a way to attempt to frighten you over such things. Anyway, let's continue on to our regularly scheduled wind portion of the meteorology segment. We'll show you global wind patterns here. So we still got a low hanging out over southern Kamchatka. These are the surface winds of the eastern world, and a triple low here south of Australia in the Southern Ocean. Here are the jet streams of this side of the planet. Highly concentrated jet stream over the western Pacific. Here are the jet streams of the western world. Huge divergence of the jet stream over the North Atlantic. Here are the surface winds of this side of the planet. Strong onshore wind there at Nova Scotia. If you're located in Nova Scotia, give a shout out to Ricky, Julian, and Bubbles from us. Surface winds of the central world are looking like this. A strong low has developed off the coast of Madagascar. And here are the jet streams of the central world. And let's take a look at the clouds and fog over the Americas. So this is our 3.9 nanometer infrared radiation satellite, part of the NASA GOES Interactive Weather Satellite Suite. It's the way that we view clouds and fog when it's too dark to use a visible satellite. Great view there. You can see the day-night terminator line rising there. That's what's going on over the Americas in terms of clouds and fog. And let's take a look at a weather map. So here's weather.gov's weather map. If your location's lit, click your location. We'll briefly scroll down to show the key. We've got some ice. Some heavy, heavy ice showing up in New England. We'll get to it. If your location's lit, click your location on weather.gov. We've also got some very cold air coming. So let's cover that first. So in about 3 days, there's going to be an intrusion of very, very cold air, which is like 20 degrees Celsius below normal for this time of year, which is already the coldest time of the year. So the coldest month of the year is mid-January through mid-February in the mid-Atlantic states, at least. And check it out. We're going to have temperatures of like at least 16 degrees Celsius below normal in large portions of Montana, especially the western part of the state, as this cold air gets shoved in from Canada by some polar air movements. So that's your temperature anomaly forecast in degrees Celsius based on the GFS model for the next 72 hours. And here is your pressure and precipitation forecast for that same period. "72-hour GFS pressure and precipitation forecast." And check out the ice that's currently happening in Vermont, New Hampshire, and Maine. Heavy, heavy icing happening up there. Looks like ice accumulation likely to be happening. Let us know if you're going ice skating just on the ground, because enough ice has accumulated to do so. That seems like it would just be awesome. Anyway, not good for driving, but good for playing in the ice if you're if you're into that sort of thing. So here's your GFS 72-hour accumulated snow depth change in inches forecast. We'll also show the Euro model. That's the GFS, and let's switch to windy.com to show the differences between the Euro model. So here's the next 12 hours of snow accumulation on the Euro model. There is the next 24 hours, and there is the next 3 days. And here are the differences between the Euro model and the GFS in terms of new snow. So pretty similar there. 3-day forecasts tend to be rather accurate. No huge differences there between the GFS and the Euro models. Continuing on, we've got our lightning mapper. We did see some heavy lightning here off the coast of North Carolina, for example, and some in the Gulf there. At the moment, we've got some heavy lightning in the Eastern Mediterranean. Some active cells there around Malta. And in the Western Mediterranean, really. So that's probably the most active lightning region in the world. Quite a bit of lightning there, actually. And next time you hear thunder, check out lightningmaps.org. It's a good time. You can forecast thunder. Maybe paint yourself as a horror movie villain. Or maybe convince the natives that you're Zeus or Thor or something like that. Don't forget to press like and subscribe if you enjoy the content. Tell your friends and foes about the channel. YouTube doesn't seem to do so. And thanks, YouTube viewers, for tolerating the pathetic, disgusting, sickening, putrid censorship on the platform. Make sure you check our playlists for videos that have nothing to do with space weather and meteorology, like Terms Defined and Do One Thing and product reviews and lots more. Help us out with clicks, perhaps by visiting the homepage at smashomash.com. We are in the process of composing a paper that plausibly explains the mechanism underlying the solar sunspot cycles and solar polar field reversal cycles. Again, if you want to support the channel, become a member of the Smash team or a patron, or maybe pick up some Hemp Lucid products. Yeah, lots of stuff to interact with us. See you on the interwebs. And let's close out the video here with some additional real-time imagery. So here is your U.S. Doppler radar map. The full 50 states of now Banana Republic former nation of ALSA, the allegedly United States of America. Still the best place to invest. Still the world's economic powerhouse, despite the constant fraud and propaganda by certain organizations. Yeah, rampant corporatism and plutocracy are trying to tear apart the fabric of life itself. Anyway, there's your U.S. Doppler radar map. How about shortwave radiation showing clouds and fog? And how about water vapor? That should clear things up if your form needs to be resubmitted and you don't have it initialized because your video took too long and now you don't have the data there. We wouldn't want that to happen, right? Right? Anyway, there's water vapor. Looks like clear skies over southwestern Arizona. It's a clear sky over Yuma at the moment. You can probably see Spica if you're currently watching the video. Anyway, here's your recap. U.S. Doppler radar, shortwave radiation, water vapor, which, by the way, is great at clearing up any Doppler radar abnormalities. So thanks for tuning in, folks. Congratulations once again on realizing the channel exists. I've been your host, Dan, a.k.a. Smash-O-Mash, signing off. And may that solar wind be at your back. Facts stated in this video suppressed by big tech organizations to improve your online experience. Opinions expressed in this video not necessarily the opinions of Smash News Network, least busted name, enough.